So guys, this program, you can see it's a factors program, and it generates a random number with a range, I think 5 to 50. So right now we're telling the user it generated a random number 33, and here we printed out the factors. Right, you can see it's got 4 factors. Right, let's try one more. So 17's got 2 factors, and the program knows that if we find a generated number with 2 factors, we know it is a prime number, so it outputs there that it's a prime number. Right, let's go take a look at the logic. Right, so let's say the randomly generated number is 6. All right, so we first need to go and find all the factors. So the way we do that is we break it down. We break 6 down into different compartments, starting at 1 and ending at the number itself. So 1, 2, 3, 4, 5, 6. Right. Now, how do we know if some number is a factor? If you say 6 divided by 1, there should be no remainder. In other words, 1 can go perfectly into 6. So we actually have a function in Delphi, mod, that returns us the remainder. So if I say 6 mod 1 is 0, we know that 1 is a factor, and we increase our factor count. So I'm just going to go put 1 here. We found 1 as a factor, and we increase our factor count. So we now have 1 factor. 1 factor, yeah. All right, that's my factor count. Move on to 2. 6 mod 2 is also 0. Okay, so 2 is a factor. And I now have 2 factors. All right, do the same for 3. Yep, that works. Go store 3 here. Notice how it's the same question you ask every time if. So you must already be thinking if statement, right? All right, 6 mod 4. Is that equal to 0? No, it is not. So 4 would not be a factor, and we would not increase the count, right? Is 5? Nope. Is 6? Yes. So 6 would be a factor, and we would increase our counter 1 more time. So starting at 1, ending at the number itself, we have found 4 factors, namely 1, 2, 3, and 6. Is it a prime number? Nope. So now guys, let us go further down. It's essentially the same steps over and over again. The only thing that changes is the number that we're applying this mod to, if I can put it like that. Essentially the same steps repeating. So we know we can use some sort of a loop. A while loop, we're sometimes not sure exactly how many times we need to loop, but in this case we know exactly how many times we need to loop. 1 to the number itself, so that's a for loop, and in this case it would loop 6 times. And it would just repeat this instruction here. The only thing that would change is here and here, and you can use the pointer or the variable that's iterating in your for loop. All right, let's look at the code. So here guys, I've initialized a count factor to 0. I've cleared whatever display is there, so the previous display is not in there. And I've populated a integer variable with a random number in the range 5 to 50. Now remember guys, when you use the random range function, you need to include math in your uses, and always go 1 past your upper limit, because it does not include the 51. It will go from essentially 5 to 50 inclusive. 5 is inclusive, but the 51 is exclusive. It will stop at 50. Right, here I tell the user what number was randomly generated, and here is the set, that repeating instruction. This is here, and I've placed it in a for loop that loops from 1 to whatever number was generated. So in the example, this would be 6. So it's is 6 mod, where does I start? It starts at 1. 6 mod 1, is that 0? What did we say? 6 mod 1? Yes. That remainder is 0. So we display it and we'd increase our counter. This for loop will complete, and then we simply need to test the I factor. If I factor is 2, that means we have a prime number. But you can see here I've said display I minus 1. Why have I done that, guys? So say for instance we choose the number 7. 7 is a prime number. So random number would be 7. This would loop from 1 to 7. And I factors would be 2. So if I were to simply display I here, we would say 7 or 8 is a prime number. Why would it be displaying 8? Because notice, guys, this for loop will terminate when I exceeds your random number. So it will go 1, 2, 3, 4, 5, 6, 7. It will iterate to 8, but then it will fail this test. So by the time I gets here, I is actually 8. So that's why I say display I minus 1, so that it displays 7 is a prime number. I hope you guys understand that. All right, let's look at the code. All right, guys, I've used a t-rich called redq1, random number, and yeah, that's it. Hope you guys understand.